The low-cost method we described has been routinely applied for the past 40 years as a compliant method for the discontinuation of pipelines. It results in isolation of the pipeline and a sustained non-corrosive environment for the duration of the suspended operation. The method relies upon the practice of mothballing, a practice used to suspend fractionation towers and process equipment within refineries and chemical processing facilities for more than 100 years. Whereas existing standard industry practices rely upon complicated physical removal of fluids, most of the fluids, the low-cost method we present relies upon conditioning of in-situ fluids so they are not corrosive to the pipeline during the period of suspended operation. The method is referred to as mothballing of the pipeline. It relies upon injection of a volatile corrosion inhibitor amine to neutralize the pH of any fluids that remain within the pipe. The method is successful no matter the volume of in-situ fluids, so long as there is an excess of volatile corrosion inhibitor present within the closed space. Whereas present industry practices results in a typical expenditure between $10,000 and $15,000, it is the case that most pipelines can be mothballed for a cost of less than $1,000. The pipeline regulations require that a suspended pipeline be physically isolated or disconnected from any operating facility or other pipeline, that the pipeline be cleaned if necessary, and that the pipeline be purged with fresh water, air, inert gas, which may include the addition of corrosion inhibitors, and confirmation and documentation that the contained fluids are non-corrosive to the pipeline. The procedure suggests pigging the pipeline to remove in-situ fluids if practical to do so, but this is not mandatory. The procedure introduces the volatile corrosion inhibitor at an amount appropriate to the volume of water that remains within the pipeline. Use of the pipeline block valves to isolate the pipeline is satisfactory. The installation of blinds at the flange sets is not necessary because the procedure positions the owner to validate the integrity of the isolation project on an ongoing basis. After depressuring the pipeline, the appropriate volume of volatile corrosion inhibitor is introduced into the pipeline at a single access fitting. Because of the volatility of the amine, the chemical will fill the vapor space of the entire pipeline unaided. Because of its affinity for water, the inhibitor will migrate into the aqueous phase and achieve a sufficient concentration to elevate the pH of the water to a non-corrosive condition greater than pH 7. If an excess of amine is sustained in the pipeline vapor space, then there is an assurance the water remains non-corrosive to the pipeline. The use of a Draeger gas sampling device with an amine-specific sampling tube is used to confirm an excess of amine is maintained in the vapor space during the isolation period. The volatile corrosion inhibitor is an amine that is delivered as a liquid. It has a high vapor pressure, suggesting it is highly volatile. Not surprisingly, volatile corrosion inhibitor amine products are dangerous and require care when handling. It is common that pipeline owners rely upon the chemical provider to deliver services associated with the transport and injection of the volatile amine during the pipeline's suspension procedure because of their specialized training and their availability of proper protective equipment. This is a schematic showing the process of the transport of the volatile amine into the pipeline and subsequent migration into the in-situ water volume. The amine is able to freely transport through any hydrocarbon liquid that may also reside within the pipeline. Maintaining an excess of amine in the vapor space assures the pH of any in-situ water will be maintained at a non-corrosive pH greater than 7, typically at a pH of 11 or 12. Now a brief look at the procedure for establishing the necessary volume of a volatile corrosion inhibitor to secure a successful project. The volume of amine added into the pipeline is designed to correspond with the in-situ water inventory. For our existing clients, we have detailed hydraulic models from which we can precisely establish the in-situ water volume. In these cases, we are in a position to prescribe a precise volume of volatile corrosion inhibitor necessary to achieve a successful suspension of the pipeline structure. For all other operating companies, we have created guidance charts for establishing the volume requirements for the amine necessary to secure a successful discontinuation. These guidelines are empirically based and have been validated to achieve desired outcomes by considering feedback from field teams that have implemented projects based upon these guidance. The guidelines consider the volume of the pipeline, the expected volume of in-situ water based upon the service, whether it's natural gas, oil gathering, or crude oil. The topographical complexity of the pipeline route is also considered when determining the amount of in-situ water and the amine volume. The guidelines are provided for projects where pigging of in-situ fluids has been possible, or in those situations where the pipeline has been suspended without the removal of in-situ fluids with pigs. Low-cost mothballing strategy satisfies the intent of the regulations, isolation of the pipeline and preservation of a non-corrosive environment. In fact, by providing the ability to confirm the integrity of the isolation and preservation of a non-corrosive environment over the duration of the suspended period, it actually delivers a better outcome than typical standard industry methods. This is an image of the Draeger gas sampling pump and an amine-specific sampling tube. The indication of a blue stain indicates the presence of volatile amine within the contained pipeline space and is confirmation that any in-situ water will be resting in a non-corrosive condition. We believe the timing is right for the industry to adopt a low-cost procedure that positions discontinued pipelines into a safe condition. It might be encouraging for those companies planning future discontinuation projects to know they can eliminate many of the complex and costly steps associated with the present industry-accepted practices. A mothball strategy eliminates the need for nitrogen purging, installation of temporary pigging equipment, and the installation of blind flanges at the pipeline block valves. We encourage you to contact us to secure mothballing recommendations for your future projects. We hope the information was interesting and helpful. Please go ahead and contact us to discuss our ideas for how our data services and engineering assessment projects can supplement your existing integrity and field chemical teams. Visit our trustedpipelineadvisor.com website to learn more of the technical details we discussed today. Thank you for watching our video post.